Just kidding. Good morning, awesome Algebra 1 students, and welcome to Monday, May 4th, aka May the 4th be with you.
All right, so for today, we are going to leave factoring behind, and I know some of you are super bummed about that, but we're gonna head on into properties of exponents and powers. So there's actually a lot of cool things that we can do with exponents, and I know some of you have seen this before because you learned it when you were in middle school, but your Algebra 2 teachers really want you to understand this concept, and that's why we're going to cover it in Algebra 1. So there are going to be 2 videos for this. This is video 1, introduction, and then after this video, you're going to want to watch video 2, which is actually called Properties of Exponents, and that will have more of the instruction. This is just more of the backstory and important things that you need to know in order to understand these different properties. So for today, you're going to want to take out a piece of paper, and in that piece of paper, you're going to want to make a T-chart. So a T-chart means on that piece of paper, you draw a line down the middle, about halfway through, and then at the top, you draw a T across so that you can kind of make 2 different categories. And what we're going to do on that T-chart is we're going to look at equivalent expressions. Now, if you remember, equivalent expressions are expressions that have the same value, but they don't look the same in appearance. So go ahead and get that T-chart ready, just like I'm about to do. Ta-da! Okay, so in your T-chart, we're going to be comparing powers to their equivalent products. And it is important that we understand how that works, just because when we get into our properties today, it just gets a little bit kind of messy if we don't understand that. So on the left-hand side, I want you to write the word power. And then on the right-hand side, we're actually just going to write, instead of writing products, I think I'm going to go in a little bit different, potentially different. No, we'll go products, power and product. Yeah, we'll just keep it simple to start. Okay, I'm going to move this a little bit closer so that you can fully see it, which means getting my share out of the way here. And this gives you a little more time to actually set up your T-charts if you haven't done so already. Okay, powers and their equivalent products. So for this, hopefully this doesn't fall over, we're going to just talk about some equivalent expressions. So let's start simple in what we already know. So if I gave you the power x squared, and I asked you to write that power as a product, what would you say? Would you say x plus x? Well, I don't think x plus x is what x squared means. So what would you say is equivalent to x squared? I would say x times x. So every power can be written as an equivalent product. That's the idea. Powers mean repeated multiplication. That's actually what a power comes from, is just multiplying the base of the power, whatever the number is, a variable, by itself, whatever the exponent tells you to do that many times. So that was kind of a simple one. That was like a warm-up one. What if I gave you, for example, what if I gave you x to the 3rd power? How could you write that as a product? Well, some of you are probably like, okay, this is way too easy. What is she talking about? Because you're thinking x times x times x. And you're technically correct. Yes, that's one way to write this as a product. Notice how I said it's one way to write it as a product. There's actually another way to write x to the 3rd power as a product. And here's how you can think about it. I have 1, 2, 3 x's that I'm multiplying by themselves. Well, what's x times x actually mean? Doesn't x times x equal x squared? I think it does. So another way that I can write x to the 3rd power is x squared times x. Because remember, x squared is just another way of saying x times x. So really, all 3 of these expressions are equivalent. There's just 3 different ways to write something to the 3rd power. So now I'm going to give you one to do on your own. X to the, you guessed it, 4th power. And what I'd like you to do is I'd like you to pause the video and come up with as many different products as you can that are equivalent to x to the 4th power. Okay, I'm just going to let you know I can come up with 3 expressions, I think, that are equivalent to x to the 4th power. And you might have come up with more, but I'll show you why I only come up with 3. Let's start with the most obvious one, which is x times x times x times x, right? We call that sometimes expanding a product or a power into a product. Well, now let's see, how else could I write this? Well, I see an x times x here and an x times x there. Well, we know from our previous example that x times x is essentially x squared. So another way to write x to the 4th as a product is x squared times x squared, right? But that's not the only way to write it as a product. If you think about it, we also have 1, 2, 3 x's here. Well, we know what x times x times x is equivalent to. X times x times x is equivalent to x to the 3rd power. So if I pulled 3 of these x's, that would be x to the 3rd power times x. And that's my 3rd way of writing this as a product. Now, you might say, well, what about x times x to the 3rd power? That's a 4th way. Well, in multiplication, the order doesn't really matter. So x times x to the 3rd is the same thing as x to the 3rd times x. So in that case, that's really just the same exact way. But the idea here is that when you have a power, there's actually more ways to write it as a product than you originally thought. So let's do one last one. And you guessed it. Our last one's going to be x to the 5th power, okay? Now for this one, just off the top of my head, I think I can come up with, I think it's also 3 different ways because order doesn't matter. Maybe 4 ways. No, I think it's 3 ways. So why don't you pause the video now and see if you can come up with the 3 ways to write x to the 5th power as a product. Okay, so the first way that comes to mind for me is we just expand it. X times x times x times x times x. 1, 2, 3, 4, 5. That's x to the 5th power expanded. Well, what else do we notice here? I see 1, 2, 3, 4 x's. So x times x times x times x, which we know is also equivalent to x to the 4th, and then plus another, or times another one, excuse me. So another way to write this is x to the 4th times x. That's just 1, 2, 3, 4, and another one is 5. What's another way? How about pulling these 3 and those 2? That would be x to the 3rd times x squared. That's another way. Is there another way? Actually, how about this way? There's probably more ways even on top of that. I see x times x here and x times x here, and then another x. Well, I know x times x is x squared. So that would be x squared times x squared times x, right? 1, 2, 3, 4, 5 total x's. And there's probably more ways to do it, even just outside of that. But that's how you can write powers as equivalent products and vice versa. Now, we kind of mentioned this before, but powers are repeated multiplication, not repeated addition. And that's where a lot of you are going to make a couple of mistakes. So we're going to go over some examples now where what does it look like when it's repeated addition, not repeated multiplication, and some things that you can and can't do when you're working with powers. So go ahead and make another T-chart just like this, okay? So another T-chart, and then this one we'll go over a little bit quicker, but now we're gonna look at how a product can be equivalent to a sum or a difference. And this is kind of dealing with misconceptions that you have when you're working with powers. So let me give you the first example here. So our first example is, what does this mean? What does 2x actually mean? Notice this is not the same thing as x squared. So 2x does not mean x times x. What does 2x actually mean? Well, some of you know, oh, 2x just means 2 times x. You're absolutely correct. But what does that mean to take x and multiply it by 2? Multiplication is actually repeated addition. So 2x, 2 times x, really means x plus x. That's what it actually means. And you know why we call multiplication times? It's because we're adding x to itself 2 times. 2 times x, adding it 2 times. So that's how you would read or write it as an equivalent sum. And then we'll look at differences later on. So what about this one? What about 3x, which is 3 times x? How would we write that as an equivalent sum? Well, this is telling me that I'm adding x to itself 3 times. So that would be x plus x plus x. Just like we were doing with our products, is there another way to write this as a sum? Well, we know x plus x is equivalent to 2x. So you could also write this as 2x plus x, and that would be equivalent to 3x's, right? 1, 2, 3 x's, 1, 2, 3 x's. They are equivalent expressions. Now the last one, or the next one, I'm going to let you do on your own, just like we did with our powers. What would 4x or 4 times x look like as a sum? And just like we did with our powers, I bet you can come up with 3 different sums that are equivalent to 4x. So go ahead, pause the video now. Try to come up with 3 sums that are equivalent to 4x. Okay, so let's start with the obvious one. 4x means 4 x's. X plus x plus x plus x. Okay, well, let's now see if we can change that into something a little bit different. For example, I see 2 x's here and 2 x's there. So another way to represent 4x is 2x plus 2x. That's 1, 2 here plus 1, 2 here for a grand total of 4. What's the third way to represent 4x? So if you remember from our work with powers, we can pull these 3 here. That's 3 x's plus 1 more x for a grand total of 4 x's. So just like powers with multiplication, you can write product using addition. So let's do one last one. Our last one is 5x, which is of course 5 times x. Go ahead, pause the video now and write out as many products as, or excuse me, as many sums as you can that equal 5x. All right, let's go ahead and start with the quote obvious one. So 5x means 5 x's, x plus x plus x plus another x plus another x. All right, that's kind of the obvious one. What else could we do? Well, I see 4 x's here plus that other one. So that could be 4x plus x. That's 4 plus 1 more is 5. We could also pull 3 here plus the other 2. So that would be 3 x's plus the other 2 x's for a total of 5 x's. And then we could pull these 2 plus these 2 plus that last one. 2x plus 2x plus another x. And that's another way to do 5 x's. And you might have more. I just can't think of them. Now, in algebra, we actually call this process combining like terms, but that's what it means. Combining like terms means taking a sum and writing it as its equivalent product. So understanding that products are repeated addition will help you avoid making mistakes when we end up simplifying powers in the next video. So that's all that we have for this video. You're going to want to go ahead and continue on to the next video where we start talking about properties of exponents, but keep these notes out, specifically these notes back here where we talk about how to write powers as expanded products. You're going to want to have those out as we talk about the next video.